Hello from an undisclosed location. This is Professor Prather for the 0324 math class on Monday, July 18th. Officially the third day of the semester, but first day that we're going to be working on math topics. So hopefully you have signed up for My Math Lab already, and I'm going to go in there right now. Here. There's two different courses for this co-requisite class. You have Math 0324 right here, and then Math 1324 there. 6 students have enrolled in 0324, 7 have enrolled in 1324. So click on the box when you want to go inside and work on it. It starts you off in this home page. And then in this class you can see the syllabus, although I emailed it out, the calendar. So we're right here on July 18th. Homeworks 1 through 3 we're going to be working on, and then every Monday, Tuesday, Wednesday there'll be videos explaining all these homework assignments in the 0342 class and in the other class as well. But in 0324 we do homework 3 days each week, and then you get 2 days for a quiz. Quizzes are only over the stuff from that week. They're due Fridays, but if you're ready for them on Thursday and get them out of the way and want to have your Fridays and weekends free, that's fine. So that's why you have a 2-day window to do a quiz. This class doesn't have any tests, and the quiz in 0324 you can do as many times as you want up to the deadline, and only the best grade counts. In the other class there's also a 2-day window for a test each week, but it's a 1 attempt only. So it may be a good idea to do the quizzes in here on Thursday, or possibly more if you need to try to get a higher score, and save that rest of the week for the test in the other class. But at least it's open for 2 days if you want to keep working on it and get a higher score. So there's syllabus, calendar, and then assignments is what you'll need the most. So all the homeworks are here for the whole semester. And then there's a quiz at the end of each week. Quiz 4, quiz 3, quiz 2, quiz 1. Each one's due on a Friday night. And all the homework for that week is due at the end of the week as well on Friday night. So you need to keep up with these as close as possible to the calendar, because once the deadline's passed, you can't work on them anymore, and then your grade is whatever it is at that point. And especially in here, you need to get 70% on every homework in order to even open the quiz. So if you're waiting till Thursday or Friday to even start working on this stuff, you're likely not going to finish it all. So we're going to do homeworks 1, 2, and 3 today, 4 and 5 tomorrow, and 6 and 7 on Wednesday. So in this class, you're mostly getting material that's taught in previous math classes before 1324, so that you'll have the skills and knowledge needed to succeed in that class. So homework 1, basic set notation, you click that, and then notice there's 14 questions total. You don't have to do them in order or even in one sitting. But every time you work on this, it'll save what you have, and you can come back and pick up later. But it does see the green flag. You must score at least 70 before you can begin quiz 1. So if this is your first time working with My Math Lab, then you will get to see how this works as I go through examples of it. So as time permits, I try to do as many examples as possible. And you'll see the homework here is a little shorter and probably won't take as long as the other class, but it'll give you some necessary skills you're going to need. Indicate whether the statement is true or false. So you get, this is a pretty basic one, just true or false. So later we'll be entering numbers in as numerical answers. You even get problems where there's a part A, part B, part C. On any particular assignment, you can click these 3 lines, and that opens up where you can jump around from question to question. There's extra help at the bottom. Help me solve this, view an example, or get more help. Textbook, that'll take you to the electronic textbook. Ask my instructor. This will send me an email with a link to the problem you're working on so I can see where you may be stuck at that point and then be able to reply back and give you some help. So every real number is a rational number. That is false because, let me show you this. So real numbers have two main branches, rational and irrational. Most real numbers are rational. Rational just means you can write them as a fraction. So anything that's an integer, because any integer could be placed over 1, all fractions, decimals that stop or repeat are rational. The irrational, there's a limited number of them. You get special things like pi. Pi is irrational. It's a decimal that goes on forever and ever, never stops, never repeats. And then square roots that don't come out evenly, like square root of 3. Square root of 4 is exactly 2, so that one's rational, but then square root of 5 would be irrational, square root of 6 is irrational, square root of 7, square root of 8. You'd have to get the square root of 9 to get another one that's rational. So at this point in this homework problem, every real number is rational, no, because there are irrational ones. And then when you answer these, this one's so easy, it's just a 50-50 guess that they only give you one chance to get this right. But later you'll see when you have to do calculations and put numbers in that they give you 3-4 chances sometimes to get one right before they count it wrong. But even when it's counted wrong, it's not forever wrong. So this one I got right, I got the green check. It lets me go to the next question. Notice at the top my score has increased now. I'm at 7%. I've got 1 out of 14 questions correct. So once this hits 70 or above, then if you're getting short on time, then maybe move on to the next assignment. But there are students that get 100 on every assignment. And the higher you get them, the higher your grade will be, and probably the better on tests in the other class and quizzes in this class you'll do. An example of a real number that is not a rational number is, here's a drop-down menu, so I mentioned this. If you can write it as a fraction, then it's rational. 1/4 is rational, that's literally a fraction. 0 and -6 integers are rational because you can put them over 1. And then the ones that are not rational are mostly the radicals that don't come out evenly, like square root of 7. And if you're ever unsure, just type it in a calculator. If there's any decimal at all to a radical, then it's irrational. Pi is another good example. There's a few special cases like that, but mostly it's radicals that don't come out evenly. So I got this one right, and I move to the next question. Now see, here's a part A, B, C, and D. So list all the natural numbers. Okay, now we got to go back to the chart. Okay, whoops. Inside of rational, we can break this down further. So rational are natural numbers. These are the positive integers, 1, 2, 3, and so on. The most natural thing a human does when they first learn math is to count things on their fingers. So that's where that came from. Later on, the concept of whole numbers came along. People realized that 0 is a number. That was a foreign concept to early humans. The Roman numeral system does not have a symbol for 0. That was discovered later, I guess you could say. And they realized if I have 6 horses and I sell them off for whatever I need, and I take 6 horses away from my farm, 6 minus 6 is 0, I have 0 horses left. So somebody thought, okay, we should have a symbol for that. So a whole new branch of numbers was created just because of that. And then you have integers. Integers is when you also include the negative numbers, but exact numbers only. So no fractions or decimals anywhere in here. naturals, integers, whole numbers, and then everything else is just a rational number. If you can do a fraction like 1/2, it's not any of these. A decimal, 0.3, those are just rational. And then if you include the irrationals, then finally you get to real. So it says list the numbers that are naturals, integers, rational, real. So these are going to have some answers in more than one category. The natural numbers are positive integers only. So, okay, I was thinking they didn't have one, but they do have one because the square root of 81 equals 9. So I don't know if they want me to put it as 9 or the square root of 81, but this is what happens in homework. Sometimes you're not quite sure how they want the answer, and then you can check it, and if they say it's wrong, okay, see how it says, although your answer is equal to the correct answer, it's not in the correct form. That's because they wanted me to literally write what was given to me, even though we normally simplify things. But so sometimes you don't know what format they want, and you just got to get it wrong. But that's the nice thing, is if you get something wrong, except in the real short answer ones, you get multiple attempts to get them right. So that's the only natural number, because nothing else is a positive integer. Nothing else is a positive exact number. Now list all integers. Integers are negative, positives, and zeros, but they have to be exact, like exactly -2, exactly 0, and exactly the square root of 81, which is 9. So once you have square root of 81 here as a natural number, it's going to be all other answers. The square root of 81 is going to be in every other answer because it's part of all these other categories. So each time you get to the next part, you're going to put all these previous answers in plus any new ones. Rational numbers are all the rest except for radicals that don't come out exactly. So fractions and decimals plus all the ones you have already. So we need -2, -3/7, 0.5, 3.5, and the square root of 81. Those are all rational numbers. And you just put a comma between each answer. Then, real numbers is everything, at least everything in this list. There are also imaginaries as well, but imaginaries are easy to see because they have to have the imaginary number I attached to them. So now, real numbers are all the rational ones we just listed, plus any irrationals. There's one and only one irrational here, the square root of 7. Because that's a radical that doesn't come out exactly. Square root of 81 comes out exactly. Okay, so that was the third one. Okay, here looks like it's multiple choice. Is the set of integer multiples of 7 a subset of the set of integers? Is the set of integer multiples of 7? So multiples of 7 are 7, 14, 21, 28. Yeah, each time you add 7, you're going to land on another integer. So yes, they are a subset. A subset means they're a smaller part. The set of integer multiples of 7 is contained in the set of integers. That's the answer there, is that if you're completely contained inside of another group, then you are a subset of it. So the natural numbers 1, 2, 3, they're a subset of the whole numbers 0, 1, 2, 3, because every natural number is inside the whole numbers. Okay, select the correct answer. If the universal set is a set of integers, is the set of negative integers the complement of the set of positive integers? Okay, so a complement is when, and let's take a smaller thing here. If you have 1 through 8, for example, you can define your what they call universal set however you want. A universal set is everything you have to work with in a given problem. They're giving me a really large one with integers because they go forever, but if I just make a smaller one, 1 through 8. If I want the set of odd numbers in this set, this is a subset of its 1, 3, 5, 7. This is a subset of the universal set because it's a smaller part of it, but everything in it is contained in the first one. And you could just arbitrarily decide to do that. I'm just making this up as I go here. But the idea of a complement is all the stuff in the universal set that's not in the one you're currently working on. So the complement of the odd numbers in this universal set are all the even ones. I haven't used 2, 4, 6, or 8 yet. And between the two, anytime you have an original set and a complement, those two combined make up whatever the universal set is defined as. So between these two, every number or item should be used once and only once up here. So you can't have any repeats here or anything skipped. So what this homework problem is asking are positive integers and negative integers complements of each other. And the answer is it's close, because the positive integers are 1, 2, 3, 4, 5, and so on. The negative integers are -1, -2, -3. So there's nothing they have in common. They're two sets that are each their own. And if we combine them together, we get almost all their actual integers, except 0 is an integer. So because we're missing 0, 0 would need to be placed in one of these two sets, and only one of them, if you wanted to say you have complements of each other. So you don't have a complement if something from the overall set, the universal set, isn't in one of the two. The union of the negative and the positives does not contain the element 0. But if we did negative integers as one set and whole numbers as another set, then they would be complements of each other, because then every number would be used once and only once. Okay, for notation purposes here, we have, if you put squigglies around stuff with a comma between it, that means you have a set. So I want to know, is the set 4, 8, is that a subset, this little sideways seeming subset, of 1, 3, 4, and 8. So it's true if everything in the first set is in the second set somewhere. 4 is in there, 8 is in there, but it has to be a smaller thing, so it would never be the exact same set. This is true because both 4 and 8 are in the larger set, and if you had like 5 and 8, that would be false because 5's not over here. So everything in the smaller set is in the bigger set. For two sets to be equal, they just have to have the exact same elements. They don't have to be in the same order. So as long as the C is there, yes. The E is there, yes. They both have J and they both have K. Order in a set doesn't matter. So you could write either set this way and they're equivalent to each other. So that's what it takes for two sets to be equivalent, is they have to have all the same elements. Number 6, they were not equal because one set only had 2 elements, the other one had 4. So I guess I need to make a list here as well. This symbol means is an element. An element is one of the items inside the set. This symbol means is a subset. So the number 3 is an element of the set 1, 2, 3, 4. Because it's literally in there. But the set 3 is a subset of the set 1, 2, 3, 4, because it's got a set of elements, but it's smaller than the original one, and everything in it is in the bigger one. And there's a slight technicalities here. For elements, you don't put any squigglies around an element. And you have to put squigglies around a subset or any kind of set. So they'll sometimes trick students by like leaving the squigglies off here or putting squigglies here when you're not supposed to have them. So little details like that are easy to overlook and miss things because of it. So 3 is not in this set, so that's false. That's not an element of it. It's literally not in there. So now I have a set and another set, and now this is a new symbol too. Whenever you have two sets, obviously they could be subsets of each other, but two other symbols are an upside down U shape and a right side up one. This is and this is or. This one's called intersection, while this one's called union. So we can do an intersection or a union of two sets. And if you have an intersection, it means and it really means you need to be in both sets at the same time. And if you have a union, it's either or both. So if I take 1 and 9 as a set and 1, 2, and 7, and I have the intersection, this means and or both. What numbers are in both sets? The only number in both sets is 1. 1 is the only one they have in common. If it turns out they have nothing in common, then you say the answer is the empty set. It's kind of like no solution in algebra. But for union, you put one of every number you see at least once. You never put repeats in an answer to a set. And remember, order doesn't really matter, but it's just easier on all of us if we put them in order. So they already have the squigglies here. I need one of each number, and I'll go ahead and put them in order. They both have 3, but I only write that once. They both have 5, I only write that once. And if this was intersection, that would be the whole answer, because they only have 3 and 5 in common. But in a union, then we also put 7 and 9 because they're in at least one set. So any number that's in at least one of them goes in the union answer. Only ones that are in both go in an intersection answer. And then this is the same thing with multiple choice. This is a union. So I want one of each number. I need a 1, a 2, a 3, a 4, a 5, a 6, and a 7. 1 through 7 is the union. That's one of every number I see at least once. If I was doing an intersection upside down U, I would say, what do they both have in common? They don't have any numbers in common. So then the answer would have been empty set, and the symbol for that is a circle with a line through it. So the union answer and the intersection answer are usually different. In fact, usually the intersection answer is smaller in size, where the union is often bigger. And if they have nothing in common, then it's the empty set. So here is intersection. I need to know, what do they have in common? 3, 4, 9, 0, 6, they don't have anything in common. So this is the empty set or the circle with a line through it if that's the choice. But here they wrote it out in words. Okay, so another way to do a set is called the listing method. So what they do is they put a squiggly to let you know they have a set. If there's variables involved, they'll put a variable with a vertical line to say that X is the variable of interest here. And then they have some kind of, they can put this like words here, or here's an equation or some kind of pattern. So that doesn't really matter, but the beginning part's just telling you what it's about. You're really just working with after the line. So if x squared equals 64, if you had that in math, you would solve that equation and get all your answers. As soon as you get all your answers, that's what they want here. So by telling me the set is defined as x squared equals 64, I can solve this. The opposite of a square is a square root. Now a square root literally means what number times itself equals that. So technically this is plus or minus, because the square root of 64 is exactly 8. But 1 times itself equals 64. 8 times 8 obviously equals 64. But it turns out -8 times -8 does that too. So we need to have both 8 and -8. If I want to write it as a set, you put squiggly -8, comma 8. Squiggly. So there's 2 numbers, and only 2 numbers, that times themselves would equal 64. Nothing else times itself equals 64. So I get a set that only has 2 elements, -8 and +8. So here's another one where they're doing it instead of as an equation. This is just like the previous problem where they're doing it in a phrase of some kind. You can describe the situation. So we have a set X such that, this is read such that line. I need a set of values such that each value is an odd number between 1 and 9 inclusive. So that is 1, 3, 5, 7, and 9. Those are the odd numbers between 1 and 9. And inclusive means including both 1 and 9. If they put exclusive, then I wouldn't put 1 or 9. I would just put 3, 5, and 7. Okay, when you do these homeworks yourself, even if you're watching these videos as we go along here, even if you're watching these videos as we go along, each problem inside of MyMathLab, they got like 10 versions of every problem. So yours might be slightly different than mine, and that's fine. That's how you learn. You can watch me do one, and then you can do a similar one. Or if you get something wrong or right, you can hit similar question and do it again. Now they want all the even numbers between 6 and 14 inclusive. That would be 6, 8, 10, 12, and 14. So this is what's nice is you can practice on the homework as much as needed. You can sometimes you guess and get lucky, or you don't feel like you really understood a question. Then you can try to force yourself and try it again. Or if you're studying for a test, there are reviews, but you can use the homework and do them more than once if you want. So once I've done them all and I'm happy with an assignment, now notice I have 100% on this first assignment. So I can just save it, or even if I didn't finish it in one sitting, you can save it at any point. And then whenever you come back, it'll be there to keep working on it. And then you have until the deadline to get the grades as high as you want them to be. So now I have done homework 1, basic set notation, and if I come over here, C-score, I have 100 on that one now. It's due Friday night at 11:59 p.m. Most students that get 100 on them, they never open them again, but you could open it and work on it some more until Friday night. Now I'm going to go to homework number 2, sums and differences. Okay, the sum of 2 negative numbers will always be a blank number. Give the number line illustration. Okay, the sum of 2 negative numbers will always be a negative number. If you're adding 2 positives or 2 negatives, you get the same sign. The sign doesn't change. 2 positives add up to a bigger positive, 2 negatives add up to a bigger looking negative. So -4 plus -3, I already know the answer is going to be negative, so I just add 3 plus 4 in my head. 3 plus 4 is 7, and then I get -7 for that. I already know it's going to be negative. Okay, when you have 1 negative and 1 positive, then it could be positive or negative for an answer. The bigger looking one will determine that. Since 6 is bigger than 3 and 6 is the one that's negative, then the sum is going to be negative. And then I don't really add them, I subtract them in my head anyway. So I would say, okay, -6 and +3, I have 1 of each. That's when I subtract the values. 6 minus 3 is 3. And then since the bigger one in the original problem was negative, the answer will be negative, -3. When adding a positive number and a negative number, the negative number has the greater absolute value, then the sum will be that one, yeah. So whichever one is bigger in size, absolute value-wise, that determines if the answer is positive or negative, when you have 1 of each. So I don't actually add, I just subtract. 6 minus 3 is 3, and then I know it has to be negative 3. So then any kind of adding of integers, or even decimals or fractions, if both of them have the same sign, you add their values together and keep that sign. If they have opposite signs, you subtract their values and pick the bigger sign. If you remember those 2 rules, then you can do any of this. 2 plus negative 1. So I have 1 positive, 1 negative. That tells me I'm going to subtract them. 2 minus 1 is 1. And then the bigger one's positive, so I get a positive 1 for an answer. See, this is all basic math right here. A student that's in 1324 is expected to know all this already. But many people don't. It's been a long time since they've seen this, or they've forgotten how to do it. So that's exactly what this 0324 class is for, is we get to practice stuff that college level students are supposed to know already. So I'm adding 3 plus negative 5. I have 1 positive, 1 negative. That's when you subtract the values. 5 minus 3 is 2. The bigger looking one is negative, so the answer is negative 2. But now I have both negatives. So when they're both the same sign, you just add them together. 14 plus 5 is 19, and then if they're both negative, the answer stays negative. Both negative, the answer is going to stay negative, and then you just add them when they're both the same sign. 7 plus 5 is 12. So when I get these, I ask myself, is the answer going to be positive or negative, and then do I add or subtract them? And then if you get longer problems, just do it a little slower. Let me come over here. They've got a 13 plus, I'm doing this for the first semester, so these videos, the videos count as part of your grade if you watch them. So your proof that you're watching these videos, I'm going to spell out a word every so often to see who's paying attention and who isn't. So if you email me the magic word of the day, then you get credit for that part of your grade. 30% of your grade is watching videos. We're going to have a video every Monday, Tuesday, and Wednesday for the 5 weeks of the semester. So today's word, the first letter of today's word is M. And as long as I don't forget, every 10 or 15 minutes I'll give you another letter in the word. I almost forgot that I was going to do one at the start and I forgot. So 13 plus negative 7 plus negative 9. So in math, we do innermost stuff first. I need to do these parentheses first. And that's just like the last handful of problems. So here I'm adding 2 negatives. Adding 2 negatives keeps the answer negative, and then you add their values. 9 plus 7 is 16. Now you just do it again. So now I'm adding 1 positive and 1 negative. Then I have to figure out which one looks bigger. 16 looks bigger. So that makes the answer whatever its sign is. It'll be a negative answer. And then when you have 1 of each sign, you subtract the values. 16 minus 13 is 3. So final answer is negative 3. That was a good problem because it had both rules at the same time. I had one where the 2 signs were the same and I added the values. I had one where I had 1 of each sign, then I had to subtract the values. Exact same problem, just different numbers. So I need to add these 2 because they're both negative. 6 plus 4 is 10, and then it'll stay negative 10. Then I'm going to have a positive 14 plus a negative 10. So positive 14 plus negative 10, 1 of each. Then I have to check which one's bigger. 14 looks bigger, that's a positive. The answer will be positive, and then I subtract the values. 14 minus 10 is 4. So the final answer is going to be 4. Now it looks like they're doing something else here. Use the rules of order of operations. Which operation should be performed first? You definitely want to go inside of parentheses or brackets. So we want to do inside the square bracket first. That's what I talked you through. That's negative 10 because you add them up and keep the negative. Now I have 1 of each, so now I subtract them. 14 minus 10 is 4, and then the bigger number is positive, so positive 4. Yep. Okay, the difference between 5 and 12 translates as blank, while the difference between 12 and 5 translates, okay. I'm not sure what they want here. Difference between 5 and 12, I guess what they mean is, what would it be written as a problem? So that would be 5 minus 12. But the difference between 12 and 5 is 12 minus 5. So that wasn't even solving, that was just writing what it would look like. Okay, so yes, if you have subtraction, subtraction is the same thing as adding the opposite. So if you want to do negative 7 minus an 8, that's the same thing as negative 7 plus a negative 8. And now you got the same rules before. Now I'm adding two negatives, so it's going to stay negative, and then I add their values. 8 plus 7 is 15. So then the answer would be negative 15 if we were actually doing it, but I guess they're just trying to teach this first. So if you have negative 7 minus 8, you can treat that as plus negative 8. Subtraction is really adding the opposite. So now they want you to do it. So think of 12, negative 12 minus 2. Negative 12 minus 2. So you can change this minus the plus, because it's easier to add things, if you do the opposite of 2 and put a negative 2 here. Adding the opposite is subtracting. Now notice I have two negatives, so that's when the answer stays negative, and you add their values. And you can really do it from here too if you get used to these, because it looks like they're both negative here too. Think of that as adding two negatives. They're both negative, so the answer stays negative, and then I add their values, 14. So either way you want to do it, the answer is negative 14. Same thing. I have two negatives. I'm going to add their values. 7 plus 2 is 9. They're both negative, so it stays negative. Negative 9. Okay. So I'll show you a shortcut to this first, but let me show it exactly like this first. Here's what you're technically doing. 8 minus negative 6. So you're trying to subtract something. So the suggestion is you do 8 and switch the subtraction to addition by doing the opposite of this number. Here it was a 2, and I did the opposite and got negative 2. Now it's negative 6, I can do the opposite and get 6. So subtracting a number is the same as adding its opposite. Or the shortcut is anytime you get a double negative like this, that switches to plus. So you'll just hear me call this, oh, that's a double negative. 8 plus 6 is what we get. And this really follows the same rule as when they were both negative. When they're both negative, you add them up and keep the negative. When they're both positive, you add them up and keep the positive. It's the same rule. If they both have the same sign, you add them and keep the sign the same. So 8 plus 6 is 14, and I keep it positive. So either add the opposite or realize a double negative will just switch to a single positive. 8 plus 6 is 14. Okay, here we got to do it a little slower now. 3 minus 6 minus 7. So let me do it this way here. I see that this number is positive 6, and I just think of this number as negative 7. It's really subtracting 7, but you could add negative 7, so you're adding negative 7. So I have one positive and one negative out of this parenthesis part. That's when you subtract their values. So I always put the bigger number first. 7 minus 6, the value is 1. Then the bigger looking one is negative, so this result right here is negative 1. That's what I would have got if that was the whole problem. Now just bring this stuff down and start over again. And now you can either add the opposite, or here's the good old double negative. A double negative is the same thing as a positive. And now I have two positives, so I add them and keep it positive. The final answer is 4. Okay, so we're winding down on this second assignment for today. A couple more problems to go. Let me give you the second letter of the magic word today. The second letter is A. Okay, here is number 15. Negative 8 minus 4 minus 12, sort of similar to the one we just did here. Negative 8 minus parenthesis 4 minus 12. Always do the parentheses first, whether they're parentheses or brackets. So ignore all this stuff on the outside for a minute. 4 minus 12. I see one negative, one positive. That's when I subtract the values with the bigger number first. Then I go back and look which one was bigger. The 12 is bigger. That one was negative, so this answer is negative. So this box right here, the answer to that would have been negative 8 if that was the entire problem. Bring all this down now. So this is a single negative right there. Don't do anything with that, but this is a double negative. So single negative, nothing happens. Double negative changes to a plus. Now I have one negative and one positive, so then I subtract them, although there's not a bigger one, so the order doesn't matter. 8 minus 8 is 0. And then you would pick the sign of the bigger one, but they're equal in size. And actually 0 isn't positive or negative ever, so 0 is neutral, so there is no picking the bigger sign if you get 0 for the answer. 8 minus 8 is 0. See, this is what the Romans discovered, is that sometimes the answer comes out to 0. And they didn't have a way to write that down. It took later on, humans later on realized it's important to write 0 down for the answer. Okay, final. I guess this is kind of weird to have this one in here, but I think this is the last problem of it. Yeah. So here's a totally different concept. I don't know why they threw this in as just kind of a last-ditch problem. But when you have bars around a number, that's called absolute value. And then you can also add and subtract these things. So absolute value of a single number creates a positive answer automatically. So whether the number is positive or negative, it turns into a positive. Or you can think of it as staying positive or switching from negative to positive. And in essence, they're like parentheses or brackets, so we should do them first. So I need to do the absolute value of negative 8, which is literally positive 8. That's what absolute value does, is it makes the answer positive. An example of it is distance. So if I get in my car and drive 2 miles to a store, I've driven a distance of 2 miles, maybe from north to south. But then after I get out of the store, if I drive back home, north 2 miles, we might want to be interested in that south is positive 2 miles and north could be negative 2 miles. There's times where we do that actually. But if you just want to know how far did you drive each time, that's what absolute value is about. Distance is positive automatically. But direction could cause there to be negatives in it. So absolute value is automatically positive. All 3 of these are going to switch to positive. And if any of them were already positive, they would stay positive. Some people think it switches to the opposite, but no, it just becomes positive. That part becomes positive. Now bring these signs down. And now you're going to finish this with what we've been doing in this whole section. So now I'm just going to go left to right, and because there's no parentheses, and do 8 plus 8. 8 plus 8 is 16, because you're adding 2 positives. And anything minus itself is 0. You have $16 and you spend $16, you have no dollars left. So this kind of, other than you had to learn what absolute value was, other than that, this is kind of a summary of a couple of things that happened in this section. Okay, I now have 100 on the second section. I did all 16 of those problems. Save. So go back into My Math Lab, and you can see here too, it shows green checks everywhere. But if I click on assignments, homework number 1, I've got 100 on that. Homework 2, I now have 100. So we're going to do one last assignment for today, and then tomorrow we'll do these 2. So tomorrow might probably won't even take as long as today did. And this one's only got 10 questions. I'm going to give you the third letter of the magic word today while I'm opening up this homework. The third letter is T. Oops, okay. That's where I was trying to go. Here we go. Okay. Okay, well, this will be similar to the last homework. Now unfortunately now we've got different rules. So I better make a list of this stuff. Whether you're adding or subtracting, it's really the same rule. Subtracting is just adding the opposite. Adding and subtracting, there's 2 rules. If they have the same sign, both positive or both negative, you add their values and keep the sign. If they have different signs, you subtract the values with the bigger one first and pick the bigger sign. Pick the bigger looking one. Those are the only 2 rules. If you know those 2, you can do any adding or subtracting problem. Unfortunately, multiplying and dividing, they have 2 rules too, but then the rules are different. And students get them mixed up. They'll get the adding rule mixed up with the multiplying rule, unfortunately. And there's no other way around it than just practice, and if you don't do it all the time, you can forget it. So multiplying and dividing, if they have the same sign, positive times positive or negative times negative or divided by, if they have the same sign, the answer is positive. And we solved that with that square root of 64 problem. 8 times 8 is 64, but negative 8 times negative 8 is 64. See, that's what's tricky, because in adding, negative 8 plus negative 8 is negative 16, but negative 8 times negative 8 is positive 64. So you can get it mixed up. If they have different signs, the answer is just automatically negative. So the rules are a little bit easier in multiplying and dividing. You're going to see that also throughout math. As you move higher and higher up into math, it's actually easier to multiply and divide things than it is to add and subtract. The rules are more restrictive in adding and subtracting. Even though back in elementary school it was the other way around, adding was easier than multiplying. So notice in the adding rules, there's 2 parts to each rule. It's what are you doing to the numbers and what's the sign going to be. That doesn't happen in multiplying and dividing. It's just what is the answer, positive or negative. But the cases when they're positive and negative are different. So 7 times 3, we're supposed to know that that's 21. So it's never about do I add or multiply or divide, but you just multiply. 7 times 3 is 21, and I have 1 of each sign. The signs are different, so the answer is automatically negative. When both signs are the same, then the answer is automatically positive. And then 12 times 11, you just multiply that. And even if you have to do this, one times 2 is 2, 1 times 1 is 1, bring down the 0. 1 times 2 is 2, 1 times 1 is 1. Add this up, 132. 12 times 11 is 132, and because both signs are the same, then it's automatically a positive answer. So whether I did 11 times 12 or negative 11 times negative 12, both of those are positive 132. Negative times negative is positive, and then I just need to do 14 times 5. 14, whoops, in there. 14 times 5. 20, carry the 2. 5 plus 2 is 7, 70. And it's positive 70 because both of the original numbers were negative. Two negatives make a positive when you're multiplying, but they make a negative when you're adding. Easy to mix that up if you don't practice enough. Here's a nice one, and this is another time where maybe multiplying is a little easier than adding, but adding is pretty easy too. For this case, 0 times anything is 0, and remember 0 is neither negative nor positive, so the answer is automatically 0. 0 times anything is 0, or anything times 0 is 0. If you've got 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 times 0, as soon as there's a 0 anywhere in there, boom, the answer is 0. 28 divided by 4, okay, this is just division. But I'm doing 2 positives, so the answer is positive, and then 28 divided by 4 is 7. Same rule as the multiplying rule. Same sign, the answer is positive. Opposite signs, the answer is negative. So negative divided by positive is automatically negative. 6 divided by 3 is 2. A negative divided by a negative is positive, and then 90 divided by 10 is 9. Positive divided by negative, one of each, the answer is automatically negative. 4, it doesn't matter if the negative is in the top or the bottom. 4 divided by 2 is 2. Now, this one's a little different. Let me make a list for this. Okay. 0 times any number, I'll just put n for any number, 0 times any number is 0. Or if it's the other way around, any number times 0 is 0. That's easier. In division, it's not quite that easy. 0 divided by any number is 0. What I like to do is look at 0 divided by a number. It looks like the word on. If it spells on, you turn the lights on, they work. That's when you can do it, and the answer is 0. But it might surprise you that any number divided by 0, this spells the word no, and this you can't even do. It won't, even if you take a calculator out and you type 7 divided by 0, error. It won't even give you an answer. So in math, we call this undefined. 0 divided by something is 0, that's an answer, but something divided by 0 is undefined, you can't do it. If I have $0 and I want to give it away to 5 people, then all 5 people can have 0 and we're happy. But if I have $50 and I want to give it to nobody, then how do I give it to nobody? There's nowhere to put the money is the problem. So that's an issue. You can't divide by 0. And in the homework, you just check, if it's 0, you actually put a 0 in this box, but if it's undefined, you just check that option. Oh, duh. But I don't have that one. I just said that one last. So yeah, I have 0 divided by a number. That's when the answer is 0. I wasn't even looking at the problem anymore. But luckily in the homework, you can get one wrong and still do it again. Now, if I want to go back to that one, so you can go back with the arrows, or you could find it here in this list. Even though I got that right, eventually I could hit a similar one, and maybe, I guess they gave me the same thing. 0 divided by anything is 0. So maybe that one's always 0 no matter how many times you do it. Okay, complete the equation to the right of the equal sign to illustrate the commutative property. Okay, commutative property says that order does not matter. So 3 times 4, 3 times 4 is 12. Well, what do you know? 4 times 3 is 12. This is called the commutative property. If you flip-flop the numbers, it doesn't make an effect on the answer. It works for adding and multiplying, actually. And this is why 0 times a number and a number times 0 are both 0, because the order doesn't matter in multiplying. But subtracting and division, it does matter. If I do 8 divided by 4, that's 2. But that's not equal to 4 divided by 8, because that's 1/2. So this is why 0 divided by a number is not the same answer as a number divided by 0. Order matters in division. But in adding or multiplying, order does not matter. And you can flip-flop things if it makes things easier. Sometimes when there's like a long string of stuff, we could flip-flop to, if I had something like a 5 plus 23 plus 7. 5 plus 23 plus 7. Maybe I want to add the 5 and the 7 first, and not add the 5 and the 23 first. So I could flip-flop the 23 and the 7 just so the 5 and 7 are next to each other and do those if I want to do those first. There are times where doing it in a different order helps. So if I have C times Q and I don't like that, I could do Q times C backwards. And that's okay if you're adding or multiplying. Okay, so when you get to the 1324 class, none of these types of problems are there, but in the problems that they're working on, some of these skills come up all the time. And then students that haven't seen this for a while, or forgotten it, or just never learned it the first time around, then they're kind of at a disadvantage for anybody that just takes 1324. But since you guys are in both classes, we have this whole extra class to go over stuff from the past that maybe you've never seen or forgotten by now. Okay, so this video here is just under an hour, and you have learned the first 3 homeworks in the 0324 homework, and that's supposed to be done on Monday, July 18th. So whether you're watching this on Monday, July 18th or not, that's what this video is for. And then each of these videos will be released on the day that you need them, and that way you can either work on that day or hopefully soon after, but definitely don't get too far behind. The final letter of the magic word today is H. So if you heard all 4 letters from today, and you might have to go back and watch the video again to hear them again if you care about that part of your grade, send me an email, and I think you can just send it to me through the D2L if you can reply to one of my emails if you want, because I'm going to be sending emails every day. Or you can just type a direct email to lonestar@lonestar.edu. And you can just put magic word or video of the day. I don't really care about the title, but just send me an email each time you watch one of these videos, and just put the magic word in the body of the email, and that gives you credit for watching this video. Now maybe somebody's going to try to scroll through, fast forward, try to find all the letters so they can get credit for that, but that's going to probably take them longer than actually just watching the video that's supposed to help them anyway. Okay, so this was the first video for 0324. 1324 is also going to have a video, so you can look for that one. They don't have magic words in theirs because that's not part of their grade. But 0324, part of your grade is watching the videos, so only in the 0324 videos do you need to send me an email with the magic word of the day. So I'm signing off for Monday, July 18th. I'll see you tomorrow, Tuesday, July 19th for 0324, or maybe you'll see me still here on Monday, July 18th for 1324.